Hello, in this video we shall see what is the relationship between pi and 180. Just I am summarizing. Pi is the ratio of circumference of a circle to its diameter, and we also saw so many figures and how the ratio converges to pi. Now when I ask question what is the total angle inside a circle, the answer I get is 360 degrees. Okay. So, what is the relationship between 360 and a circle? There is at least some relationship between pi and a circle, because pi is derived from a circle itself. But what is the relationship between 360 and a circle? Ancient Sumerians, they thought Earth revolves around the sun in 360 days. So, to track the motion of the sun, they assigned the value of 360 to describe the circle or the total angle. And one more reason is 360 is a very highly composite number. So, what is a composite number? Let us say take a number 10. What are the factors of 10? So, we know it is 1, 2, 5 and 10. These 4 are the factors of 10, correct? Now, take a number like 24. Now, 24, what are the factors of 24? 1, 2, 3, 4, 6, 8, 12 and 24, right? So, the number of factors of 24 is much more than the number of factors in 10. So, consider 360, the 360 has so many factors. So, that is one more reason why we practically find 360 to be more convenient to be used in a circle, especially when we use division and other mathematical operations. 360 is much more convenient for us to use. So, even today for all practical purposes we use degrees and we do not use values in terms of pi to describe circle. Maybe in formulas we use pi, yes, but when we use degrees we use 360 still. And we know that the total circumference of a circle is 2 pi r. Now, from the same idea we are just going to, so we know that total is 2 pi r, okay. So, what will be half of it? Half of it is pi r, okay. So, the total is 2 pi r and half of it is pi r, okay. So, this total arc, the length is pi r, note it down, and this radius is r, okay. And what would be, let us say, let us take a smaller circle. The smaller circle, what will be the semicircle circumference? It would be pi into m. Let us say the radius of the smaller circle is m. So, the semicircle's circumference is pi into m. Now, I am taking a quadrant. So, the angle enclosed is total is 2 pi. So, the value is pi by 2 into r. Similarly, for another value pi by 6, the arc length. So, we used to call that as arc length. So, this is called arc length. So, the arc length, if the angle is pi by 6, the arc length value will be pi by 6 into r. So, this is much more convenient. This is very similar to what we have seen in earlier videos. So, now if we have a random angle, say theta, then we can say that we simply can find the arc length by multiplying this value theta into r, okay. So, we saw the total angle enclosed, we know that is 360 degrees, but that degree value is not useful in our calculation. The degree is not used in the formula of the circumference of the circle. We are using a value in terms of pi. So, the total circumference is 2 pi r, and if the radius is r, the total angle is 2 pi, okay. So, the total angle is 2 pi, so half of that angle will be simply pi. So, everywhere when it comes to applying in formulas, we apply in terms of pi. So, what is this? So, this is called radians, and whatever we measure in terms of degrees, like the full circle is 360 degrees, if we convert that in terms of radians, we get it in terms of pi. So, which is more close to circle? The radian is close, right? We cannot directly apply degrees in the formula. So, we use radians. So, pi is same as 180, except that pi is in terms of radians and 180 is in terms of degrees. So both are same, it's only the scales are different, like it's like liters and ml. That's one scale of conversion, right? So pi is in terms of radians and 180 is in terms of degrees. Now in calculations, of course we use it in terms of radians. So how do we convert from radians to degrees or from degrees to radians? Let's see the formula as well. To summarize, pi or 2 pi is in terms of radians, 180 or 360 is in terms of degrees, but we cannot directly apply degree in area or circumference formulas. We have to convert that in terms of radians. So how do we convert? So it's fairly simple, right? 2 pi corresponds to 360, pi corresponds to 180. So how do I convert, let's say, how do I convert 30 degrees? In the earlier slide, I used 30 or I equated 30 to pi by 6. So how do I convert it? So this is the conversion formula. So to find if the value is given in terms of degrees, for example, let's say if the value is given as 60 degrees, to convert that to radians, so 60 into 2 pi divided by 360. So what do I get? I will cancel this and I will get pi by 3. So 60 in terms of radians corresponds to pi by 3 in terms of degrees. Similarly 90, so you can do, so the very often used values are 60, 45, 90. So basically we can use these values. So I expect the students to substitute these values here in the degree term and then convert that to radians and check it. If the values are given in terms of degrees, how do we find the area and circumference? So we know the conversion formula. So the idea is to convert that in terms of radians and then to substitute in the formula. Okay. So we know area. So area of a full circle, we know the value is pi r square. So if we are finding the area of a semicircle, it is pi r square by 2, right? So we know the value is 180 degrees. So if the value is given in terms of degrees, it's very simple. 180 divided by 360 into pi r square. Okay, whatever value you have for area, so 180 divided by 360, that will give this area. And let's say circumference of this semicircle, it's again 180 by 360 into 2 pi r. So area, full area is pi r square. If I want only for 180 for this alone, it's 180 by 360 into pi r square. If I want only for, if I want the circumference, it is 180 by 360 into 2 pi r. So I hope this video helped you to understand the relationship between pi and 180, and if the values are given in terms of degrees, how to find the area and circumference. I hope you all learned it. Thank you.